A box with a mass m is dragged across a level floor with the coefficient of friction mu and kinetic friction, so by a rope that is pulled upward at an angle theta above the horizontal with a force of a magnitude F. A, in terms of m, mu, subscore k, theta, and g, obtain an expression for the magnitude of the force required to move the box with a constant speed. Okay, and then B, knowing that you are studying physics, a CPR instructor asks you to know how much force it would take to slide a 90-kilogram patient across the floor with a constant speed by pulling on him at an angle of 25 degrees above the horizontal by dragging weights wrapped in an old pair of pants down the hall with a spring balance. You find that the coefficient of friction is 0.35. Use the results in answer A to answer the instructor's question. So first, we'll set up a free body diagram of what we're trying to solve. So there's our box. It has an mg and a normal force upward. Oh my gosh, it's so tall. And then it has friction, so we're saying this is the positive way that's pulling. We'll draw our rope with a force of F and has friction going this way with force of F of K. Okay? F of K. So there's our free body diagram. Then we can set up equations for X and Y. I'll do it over here. X is going to equal F for the force cosine of theta minus the force of friction is equal to 0. So then F cosine of theta is equal to the force of friction. And then we're going to say that using force equals and friction equals normal force times the coefficient of friction, we get normal is equal to F cosine theta divided by mu k. So then we're going to take y, the y direction, and look at the forces there. And the y direction is going to equal the normal force plus force sine of theta is minus mg is equal to 0. And then, so then the normal force is equal to mg minus f sine of theta. So then we take these two things and we can set them equal to each other. So then f cosine theta is equal to mu k. And this is part A. Mu k times mg minus f sine of theta. Woo! So then, we can get the force to the other side. We can say force times cosine, oh my gosh, theta plus mu k sine of theta is equal to mu k mass times gravity. Then the force is equal to coefficient of friction times mass times gravity divided by cosine theta plus coefficient of friction times sine theta. So there's our answer for part A. Then B, we'll look at over. B, we'll look at here. B, we have a mass of 90 kilograms. Theta equals 25 degrees. And our coefficient of friction, it told us, is 0.335. So then we can just plug everything in to our equation from here, and we get that the force is equal to 292.8 newtons after you calculate it.